Welcome to the video for C3.1.7 where we're going to look at mole calculation. So pause the video and see if you can have a go at this start. Okay, so hopefully we've used ratios for this. So this recipe serves 10. We only want to make enough for 2. So 10 divided by 2 is 5. So I just need to divide all of these quantities by 5. So 120 divided by 5 is going to be 24 grams. 100 divided by 5 is going to be 20 grams. So I need 24 grams of butter, 20 grams of dark brown sugar. I need 4 over 5, so 4/5 of a tablespoon of golden syrup. 250 divided by 5, so 50 grams of oats. And 40 divided by 5, so that's going to be 8 grams of sultanas or raisins. And then for 9, you just do the same thing. That would give us 108, 90 grams, 3 3/5, 225, 35, 6. Okay, so what's this got to do with chemistry? So we can use this idea in chemistry when we're trying to work out reacting masses. So you can pause the video if you want to read all the learning objectives, but I'm not going to talk you through all of them. So balanced equations we've met before. So the balanced equation tells us how much of each substance is involved in a chemical reaction. So these numbers in front, so there's a 2 there. There's no number in front of there, but that effectively means there's a 1 and there's a 2 there. So what that means is that 2 molecules of hydrogen react with 1 molecule of oxygen to give 2 molecules of water. So this gives us the ratio of these chemicals. But we can also do this in terms of moles. So if 2 molecules of hydrogen react with 1 molecule of oxygen, then 2 moles of hydrogen will react with 1 mole of oxygen. So it also gives us the ratio of the moles. And this is useful because now we can use it to work out any masses that are involved in our chemical reactions. So there's 2 methods that we can do this. We can just do it by ratios, which is what we did in our starter with the flapjacks, or we can use the concept of moles to do it. So if we can work out using relative formula masses and relative atomic masses, we can work out the mass of this. So this 2 times 2 means that there's 4 hydrogen atoms, and each one of those has a relative atomic mass of 1. So the mass of that's going to be 4. And this means I've got 2 oxygens, and each oxygen has a relative atomic mass of 16. So that gives me a total mass of 32. And if I work out the relative formula mass of water, that's 16 for the oxygen and 2 times 1 of the hydrogens, that's going to be 18. But I've got 2 of those, so 2 times 18 is going to be 36. So what that means is that 4 grams of hydrogen reacts with 32 grams of oxygen to give me 36 grams of water. Now, if we've done this correct, then from conservation of mass, we know that the mass of the reactants equals the mass of the product. So 4 plus 32 gives us 36. So we know that we can be confident we've done that correct. So we can use this to work out how much water would be made if 3 grams of hydrogen was bought. So from these ratios, 4 grams of hydrogen gives us 36 grams of water. So what that means is I can use ratios. So if 4 grams gives me 36 grams, 1 gram is going to give me 36 divided by 4 grams, which is going to be 9 grams. Because if to get from 4 to 1, I've divided by 4. So I also need to divide this mass by 4. And 36 divided by 4 is 9. So 1 gram of hydrogen is going to give me 9 grams of water. So 3 grams. So to get from 1 to 3, times that by 3. I also need to times the product. So it's going to give me 9 times 3 grams. So that's going to give me 27 grams water. So the other way we can do it is by using moles. So if we're going to use moles, we write an equation like this. And we fill in the information that we already know. So on the molar mass is the relative formula mass. If we had just elements by themselves, which weren't diatomic, we'd use the relative atomic mass. but all of these are molecules. So we'll steal those from the previous question. So when we're doing this, we're going to ignore any number in front of it in the equation. So the molar mass of hydrogen is 2 times 1, which is 2. The molar mass of oxygen is 2 times 16, which is 32. And the molar mass of water is 2 times 1 plus 16, which is 18. Now it tells us 3 grams of hydrogen. So I'm going to put that into the mass, which is here. Now we're only interested in the water and the hydrogen here. So we're not interested in the oxygen, so I can just cross that out. So what I'm now looking at is when we do this, one of these chemicals will have 2 boxes filled in, so we can work out the other quantity. So if we remember from our last lesson, number of moles is mass over molar mass, or relative formula mass in this case. So I can write this into here. So now my number of moles of hydrogen, so I've got the mass and I've got the molar mass. So I can work out the number of moles. So the number of moles is the mass, which is 3, divided by the relative formula mass, which is 2. So it's going to be 1.5. And if we look, we now need to look in our equation, and we can see that 2 moles of hydrogen gives me 2 moles of water. So that means if I've got 1 mole of hydrogen, that's going to give me 1 mole of water. So if I've got 1.5 moles of hydrogen, I'm also going to have 1.5 moles of water. And now I've just got the mass missing. So we can rearrange this equation to give mass equals number of moles times by relative formula mass. So I can now stick my figures in. So the number of moles we've worked out is here is 1.5. And we times that by relative formula mass, which is 18. And if we do that, we come up with 27, which is exactly what we got on the previous slide. So whichever method you use, you should get the same answer. Now, it doesn't matter which method you can use. You can use the ratios, or you can use this table on and working out the number of moles. Whichever method you prefer, you can use. Okay, so there's 3 questions here that I want you to have a go at. So pause the video, have a go at these questions, and then unpause the video and check your answers. And you can use either method 1 where you just work out the ratios, or you can use method 2 where you work out using the number of moles. Okay, so hopefully we've come up with 162 grams for the first question, 19 grams for the second one, and depending on where you've rounded it, 7.1 grams if you've rounded it, or 7.3 grams if you've left it in your calculated value throughout the question. Okay, so there's a worksheet for you to have a go at. Have a go at answering them and then check your answers on the answer sheet. Okay, thank you for listening. See you next time.